Hello, this podcast involves problem solving. Specifically, we're going to look at three ways to solve problems: dimensional analysis with conversion factors, dimensional analysis with units, and problem solving with proportions. So first, let's look at problem solving using dimensional analysis with the factor label method. This is very similar to unit conversions, only in this case we're converting from one quantity to another. So instead of converting from one type of unit to another, such as from meters to kilometers, all within the same quantity, now we're switching between quantities. For example, what volume of gas can we buy with $20 if gas costs $3.92.9 per gallon? Well, in this case, we're starting with a dollar amount and we need to wind up with a volume. So we can set this up as a conversion factor, but we're not converting within the same quantity. We're going between quantities. But this is a very useful way to set up problems, especially when you're not quite sure whether you should multiply or divide by a certain number. So let's take a look at the steps. Step one, we need to find an equality statement or a combination of equality statements that relate the original units to the final units of the answer. So in this case, we're starting with dollars and we need to wind up with gallons. Well, in this case, 1 gallon is equal to $3.929. So that's our equality statement. Now, as it says up here, you may need to use multiple equality statements to get from your starting units to your ending units. In this case, we just need this one. Second, create two conversion factors from each equality statement. So we have one equality statement, and we can create two conversion factors. That's $3.929 over 1 gallon and 1 gallon over $3.929. So we need to, in step 3, multiply the original measurement by the conversion factor or factors that cancel out the original unit and leaves you with the final unit for the answer. Well, in this case, we start with $20, so our conversion factor has to have the gallons in the numerator and the dollars in the bottom, so the dollars cancel out. We go ahead and perform the calculation, and we're left with 5.090 gallons. Note that the 1 gallon and the $3.929 are exact numbers, and then the sig figs in the $20, 4 sig figs. So that means our answer will have 4 sig figs. So this is dimensional analysis with the factor label method. Now we can do dimensional analysis with units. And this is helpful because we can determine the mathematical relationship between variables by using units. So for instance, if you forget Newton's second law, and is it force is equal to mass times acceleration, or is it force equal to mass divided by acceleration? This is the type of problem that dimensional analysis with units can solve. So in this case, we're going to look at how our time, distance, and velocity related mathematically. So I'm not going to refer to any equation. I'm just going to let my units determine the equation. So first step is, what are the units for each of the variables? Well, in this case, the velocity is in meters per second, time is in seconds, and distance is in meters. So step 2, we create an equality statement with the units. So I have velocity as meters per second. Well, how can I get meters per second on the other side of the equation? Well, I simply do meters divided by seconds. So notice the units are equal to each other. So now I want to substitute the variables for the units, and I want to change the equal sign to a proportional sign, which is the lowercase alpha. And so meters, well, that's displacement, or delta x, divided by, well, seconds. The variable for seconds is time, and that's proportional to the velocity, because velocity is the unit for meters per second. So one thing we need to talk about is why do we use the proportional sign instead of the equal sign? Well, when we use an equal sign, that means that the number on the left-hand side of the equation has to be exactly the same number as on the right-hand equation. And sometimes there may be numerical constants in the equation, and dimensional analysis won't tell us that. So that's why we use a proportional sign. Now in this example, we know that there aren't any numerical constants in there. We know that velocity is equal to delta x divided by delta t. So again, this is a useful way to figure out mathematical relationships just by using the fact that the units on the left-hand side have to equal the units on the right-hand side of a math equation. Finally, let's take a look at problem solving with proportions. We're pretty good at problem solving when we have numbers to plug into an equation, but we also need to learn how to solve problems when there are no numbers. And so we can solve equations without numerical measurements by using proportions. Let's take a look. Here's a problem. How far did car A travel compared to car B if it traveled twice as fast in 1/3 the time? Notice we've got proportions. Car A is moving twice as fast as car B, and car A is traveling 1/3 the time of car B, but we don't have any specific numbers. Still, we can come up with an answer to this question. So step one, we need to find the correct equation or set of equations. So in this case, we know that distance is going to be equal to velocity times time. Second, we need to write the distance equation for both cars. Using subscripts in this case is very helpful. So this comes up with the distance of car A is equal to the velocity of car A times the time car A was traveling, and similarly for car B. Step 3, we need to write the equations for the given proportional relationships. So we have to go back to the word problem, and that tells us that the velocity of car A is twice the velocity of car B. And this is how we write that as an equation. Similarly, the time car A was traveling is equal to 1/3 the time car B was traveling. Step 4, we want to substitute the B values into the right-hand side of the original A equation. So we're going to take these values and we're going to substitute them up here in the original distance equation for car A. And that leaves us with the distance car A travels is 2 times the velocity of B times 1/3 the time B was traveling. And that equals 2/3 times V sub B T sub B. Step 5, we want to use the original B equation to substitute for the variables on the right-hand side of this equation. So notice up in step 2, we have the original equation for the distance B traveled. D sub B is equal to V sub B times T sub B. Notice we have a V sub B times T sub B in this last equation in step 4. So we can substitute D sub B in for V sub B times T sub B. And that leaves us with D sub A is equal to 2/3 D sub B. So the answer to our question is car A traveled 2/3 as far as car B. So problem solving with proportions is an important tool to have. It especially helps us have a deeper conceptual understanding of what's going on, and it breaks us away from relying on our calculators. And again, calculators don't replace our knowledge or understanding. They are just tools to help us solve complicated numerical problems. But we still need to be able to solve problems proportionally without the use of a calculator. So I hope these 3 problem-solving tips are helpful to you and that you found this podcast useful.